Hi, I'm Abhishek Peris. I will walk you through the vulnerability we found and more importantly, exactly how we fixed them. We started with the brute force attacks, where attacks try many passwords until one works. To stop that, we enforced the strong password rules, added the recapture on login pages and sign up pages, and implemented the automatic loggouts after repeated failures. If a user triggers the logout, they see a clear messages and guided to contact the admin to restore access. Simple, fewer guesses, fewer breaches. Next, session hijacking, where an attacker steals a user sessions to impersonate them. We had sessions by using a secure session secret, disabling unnecessary session receives, and only saving initialized session when needed. Our session cookies are HTTP only and time limited, 1 hour by default. So client script can't read them and all sessions expire automatically. We also initialize passport correctly so authentication state is handled safely on every request. Finally, man in the middle attacks. We move all the sensitive traffic to TLS using valid SSL certificates. On the server, we load our key and search securely, ensuring every connection is encrypted end to end. This prevent attacks from the either dropping or tampering with the data in transit. So, previous sites using the HTTP URL, but I use the HTTPS for the defense the man in the middle attacks.
Rest of the interactive solution integrated management system while focusing mainly on security aspects. So in my part, I have identified two vulnerabilities, which is cross-site scripting attacks and NoSQL injection. In our project, I have implemented security measure counter cross-site scripting vulnerabilities using the successful library. This library helps prevent the attackers from injection malicious scripts or query from the front end, such as attempt is made, the system will trigger a message. For example, on the request page, I have added some malicious code in item name and the user email. So in this here, only allowing for alphanumeric characters. That means if user attempts to input something like non-numeric value or like display like numeric character detected. And also I have here I will show the error like please enter valid email address as well, because I have added the validation for to email to similarly I have applied XXX protection for search functionalities as well like this. And it also gives a invalid character detectors. Here if we use script like it will display an error. And also after adding script tags for code like this, and then click on the register button, also register form, and it's also same and give the errors as well, the prevent for API call from being executed from the front end side. And yeah, for example, you can see the script tag save button and register button, and also give the errors, right? And I'm now moving for the NoSQL injection part. To safeguard for our project against NoSQL injection, I have taken several precautions for primarily focusing on the input validation and the Mongo Sandbox packages. This package also serves as a middleware for added security, whether it's request body, path variables, query parameters, or header of system, ensure the no malicious database scripts is passed through. For example, uh, I have when I log in some using valid email, the process as expected. However, the considers are like this in the like this malicious MongoDB query subsystem. It's the help of MongoDB syntaxes and transform it, the preventing the unintended extension. The queries or show as errors like message is like invalid payload, and it's not allow for like non-numeric characters for email and the other stuff. So yeah, and also enhanced database protection, and I have utilized the escape default encoder for seeing the JavaScript file the code. Now, when you using some function with the product ID, even they input malicious query in our system, it encode and save different in the databases. And yeah, so this is my part, and also I have implemented the auth using Google and Facebook. With we can use login using this button. For example, when you click the Facebook button, it's login successfully for using Facebook, and you can use your Facebook email and password. You can success login successfully. Thank you. That's my part.
Broken access control, insecure object preferences, vulnerable JavaScript library. So when you present broken access control, that occur when application allow to users the access resources that they shouldn't have access, and the insecure object preferences occur uh, then application users allow to access sensitive data or operational on object that they shouldn't have access, and the vulnerable JavaScript libraries happen in application use old or unsafe library with security flaw. Hackers can use it to attack the system or steal data. So when we consider the broken access control, uh, here we try out the get customer data using admin cookie. Here get the message, you are not authorized to access this resource. So these are used for the access profile section and shopping cart. Before they access these resources, user must log in the system. So when we consider the insecure object preferences, here we try out the edit admin details using customer cookie. Here then see you are unauthorized user. So when we consider the vulnerable JavaScript library, so prevent this, I will you so check this. I will use this command to an adult command. uh, Here see zero vulnerabilities, and because here I will remove the old version and update to new version. So that's all about my part. Thank you.
My IT number is IT22006820. In this project, I fixed three vulnerabilities: cryptographic failure, timing attack, and broken authentication. Let's move on to the cryptographic failure. This happens when sensitive data such as user passwords are stored or transmitted without strong cryptography. In this original code, password was stored in plain text, which means everyone who gained database access could read them. I fixed this by hashing passwords with the bcrypt algorithm and configurable number or salt rounds taken from environment variables. Here I assigned salt rounds as 10. Now the password is never stored in plain text. Here's the demonstration. You can see once we register a new user, that user is stored in a database and their password is stored with bcrypt hashing. With this approach, broken authentication vulnerability is also fixed. So broken authentication occurs when login or session management is weak, allowing attackers to impersonate users. Apart from the above approach, I generate a JWT token with strong session key stored in the .tnv file, not hard-coded in the source. So let's move on to the timing attack. A timing attack happens when the time taken to compare secrets like password leaks information. If we use a simple string comparison, an attacker could measure response time to guess the password character by character. We prevent, here you can see, uh, We prevent this by using bcrypt.compare, which means performs a constant time comparison of hashed password and the user's input. This eliminates the timing, side channels, and protects against brute force guessing. In summary, I secured this system by hashing passwords to prevent cryptographic failure, using constant time comparison to stop timing attacks, and strengthening authentication with JWT secrets. These measures significantly improve the overall security of our application. Thank you.